Do we have mathematical proof that humans can be psychic? On first glance, yes. On a closer glance, we still do. This is the distribution that you would expect if humans were not psychic at all. And after tens of thousands of trials, we got this distribution significantly off to the side. Although on closer inspection, it gets a bit more interesting.
This video is sponsored by Jane Street's paid internships. Applications for Hong Kong, New York and London are open now. Details in the description.
The test we did involve these, Zener cards. These have 5 different symbols on the back, square, star, plus, wavy lines, etc. We'll put them on the screen so you can see them. And we'll actually do a quick test round with you watching this video right now. So, which card am I holding? You gotta guess. There are 5 different symbols, 20% chance you're gonna get this right. Lock it in. Correct answer was wavy lines. There you are, wavy lines. If you're card counting, you can remove that from the deck now. Okay, 1 in 5 of you are still in. Or you can keep playing. What do we got now? It's circle. There you are. A fifth of you are very excited right now. What's this one? Circle again, Just because they're random doesn't mean you're not going to get the same symbol twice. Finally, we got this one, which is plus symbol. And last, we have square. Fun fact, for every 100,000 people watching the video, 32 of you, on average, are freaking out right now. Good job. Mathematically, this is a really nice, neat situation. Ignoring ESP for a second, because every single card, there's just a 1 in 5 chance you will correctly guess star. So, if they're 20% chance each, you can ask questions like, well, if you do 5 guesses, how many should you get right on average? What's the distribution? Obviously, some people got all of them, but what's the distribution across everyone who played a moment ago? And because it's such a good teaching aid, a maths teaching friend of mine, Ben Sparks, back in early 2021, during the lockdowns in the UK, put together an online version of this that they could use in online maths lessons. And to explain more about that, I'll quickly use my psychic abilities to get in touch with Ben.
Ben, tell me about your website.
You want to know about the website? Excellent. This is a website that I made, or rather my brother made for me because I asked him nicely and paid him to demonstrate what happens when we test people's psychic abilities to pick some cards. So there's the basic idea is there's a hidden card and you pick a card that you think it might be. That's the simple idea. You can run a 5 guess version or a 10 guess version or a 25 guess version. And I'll just try a 5 one. You can click start and then you don't know what the card is, but I'm going to guess it's a star. It wasn't. And never mind. I'm going to guess it was a square. It wasn't. What about square again? No. Waves? No. Square again. I got 0 out of 5. Maybe that's surprising in itself. I would expect by, random chance to get about 1 in 5. On average, it's a 1 in 5 chance after all. This is the game though, and you see it's making a nice little bar chart of what's happening. If I play the game again, hopefully... Oh, I got 1 right! Sorry. Oh, 2 right. I'm dead impressed. 3 right. Save this one. And you can see that my bar chart is updating. I've now got a trial that had, or rather, a run of 5 trials that had 3 right. The reason I got my brother to make the file was to demonstrate what happens with a statistical distribution when you run it enough times, and I was using this in my online maths teaching with school children to demonstrate some statistical properties.
Now we just need to play Ben's game loads of times to get the distribution, so we'll set that going, a time lapse. You might be wondering why we're using these symbols, like why not use anything? Well, these are Zener symbols, and these have an interesting history with psychic research. They've been used a long time by people who claim to be investigating whether or not humans can be psychic, so they add a little bit of pizzazz to what would otherwise just be a maths lesson about probability. And I can say, before us, no one ever had any conclusive evidence of any kind of psychic ability involving these. Any claims of psychic ability always involved misreading the stats or some kind of confounding factor. But will that be the case for us?
So these are ESP cards, otherwise known as Zener cards, and they were developed in the 1930s by a chap called Carl Zener, who worked at Duke University in America, and his colleague Dr. Joseph Banks Rhine. Now, these were developed for testing ESP, psychic ability, and there are 5 different designs we have: circle, cross, wavy lines, square, and star. So the reason these were picked is because they ascend from a single line with the circle through to 2 with the cross, 3 with the wavy lines, 4 with the square, and although not lines, points with the 5 points of the star. Joseph Banks Rhine and Carl Zener performed what they say to be around 90,000 experiments with these and claimed that ESP was an actual and demonstrable occurrence. When we think about the validity of these tests, the original ones conducted by Rhine and Zener, there were a lot of issues with them. The cards were not properly randomized, that was a big issue. The participants were able to get access to them at times before the experiment was done, and some of the earlier ESP cards, they were printed in such a way that they were embossed a little bit, and with the right light, you could see the design from the back of the card. To this day, there has been no legitimate, robust, actual statistical evidence that there is anything going on with the ESP cards at all. So part of what I do as a stage entertainer is inspired by the world of the strange, the weird, and the spooky, and obviously I had to get the ESP cards on my arm.
We can check back in with multiple trials on Ben's version of the game, and as you can see, we are approaching some kind of shape, like a distribution of how many times we got a certain number of cards correct. But to explain what that shape is, much like my video debunking the Dream Minecraft speedrun, we need a binomial distribution.
Now, you may have heard the word binomial when it comes to expanding something like this. You get the binomial expansion, A plus B squared. Or you could do a higher power to the 5th power. There's your binomial expansion of that. And if you look at the coefficients in this first one, that's like 1, 1a, 1, 2, 1, and down here 1, 5, 10, 10, 5, 1. So that's binomial expansions. We can see how that ties in if we do a probability tree diagram for either getting things right with a probability p or getting them wrong with a probability 1 minus p. So that's just the first time you guess a card. Now, if you got it right the first time, there's a chance you might get it right again. That's an overall chance of p squared, or you might then get it wrong. The probability of that happening is p times 1 minus p. However, what if you got it wrong to start with and then you got it right? Well, that's still p times 1 minus p, but there's 2 ways you can do it. So we add them together, you get a 2. And then, of course, you could be super unlucky, you get it wrong again, 1 minus p squared. Interesting, the coefficients are 1, 2, and 1. And where have we seen that before? Now, of course, we can keep going. If we did it a 3rd time, you'd have all these new options. Coefficients are 1, 3, 3, 1. We could do it a 4th time, and you get these values. You do it a 5th time, and you get these values. And the coefficients are 1, 5, 10, 10, 5, 1, and you've got every combination of the powers there. Once again, you're like, that reminds me a lot of doing the binomial expansion, and that's why they have the same name. And as some of you know, you'll see these numbers in Pascal's triangle. The point is, if we evaluated these 6 terms, we have the probability for getting 5 correct, 4, 3, 2, 1, and 0. We could take those values and plot them, and I've done that for probability 1/2, which is why it's symmetric, and that's getting 5 correct, 4, 3, 2, 1, 0. Sorry, it's flipped around the other way. You get the idea. So if we had more guesses in a row, we get these more spread out distributions, and for the case of just 5 guesses, it looks like that. Now, for Zener cards, the probability of success is all the way down here at 0.2, which skews everything over in the getting fewer correct direction. If it was way more likely, it would skew it to the right, but no, it's down here at 0.2, and you can see this is how often we'd expect people to get 0 right, 1, 2, 3, 4, or 5 is tiny, and then if you have more trials, you can see it just moves the distribution around. Now, interestingly, here, for the case of 5, you get 1 correct over 40% of the time. That's almost 41%. Isn't that phenomenal? So this is the theoretical distribution we should get if it's completely random, and as you do more trials, it should approach that.
Where this story initially gets interesting is to get some kind of significant results, or to get close to the distribution it should be, or to not get close to the distribution it should be. You need a lot of trials. You need so many people doing this, and that's often the difficult part with an experiment like this. Ben, however, got lucky by accident. After he made the website and used it in some online lessons, he just left it, and then Google search found it. It's now the 2nd top ranked link if you search for Zener cards, after the Wikipedia page about the Zena symbols. So anyone searching for it for the last 4 years has found Ben's website. He's accidentally become the go-to test. He has now got over 27,000 trials of people trying to guess these cards. And that means we can have a look at the stats and know any deviation must be significant.
Let me show you all the results that we've got for the 5-card trial. Here is the graph. The red bars are the actual data we've got. And actually the other lines on here, these lines with the dots at the top, that is the distribution I would expect if people are guessing. Guess what? I think they're guessing. You can see that getting 1 card out of 5 is the most common outcome, and I hope that's not too much of a surprise. It's a 1 in 5 chance. The other outcomes are possible.
But Ben, what about the others? 10 and 25.
Oh, you want to know about the others? Well, we can look at the others as well. The 5 did exactly what I expected. If you look at the 10 results, they are also pretty close to what I would expect. Again, the red bar is the data we've actually got. This time, only 5,000 results. Less popular, the 10-card game. I don't know why. The black lines with the dots are the expected distribution, a binomial 10 trial, 1/5 chance of getting it right. You can see we've got fewer people getting 0, slightly fewer than I might have expected, but it's not a million miles away, and it's not far enough away that I am suspicious. We've only got 5,000 results. I mean, most of the time that's quite a lot of results, but compared to the other one, we haven't got as many. And the distribution is kind of what we'd expect. Again, nobody's got these extreme high marks. No one's been hacking my system. But you want to know about the 25, right? And so this surprised me. I said that nobody got 8, 9 or 10 out of 10. Actually, that's not true. I did a quick search through the data. Somebody's done quite well on this 10 trial one. Actually, they've only tried the game 4 times. The first time they tried it, they got 2 right. Went in that line. The second time they tried it, they got 1 right. Maybe they were frustrated. I don't know. Third time they tried it, they also got 1 right. And then 1 minute later, they tried it again and they got 10 out of 10, which I'm amazed about. Interestingly, I checked carefully. They've never played the game again. And I don't blame them. Quit while you're ahead. It is fantastically unlikely that anyone's done that, but with 5,000 people, there was always a chance, and it looks like someone did it. I wonder if we could find them, Matt.
Yes, if that's you, get in touch. But I guess, Ben, if only one person did that once, it's not evidence of cheating.
If people were cheating, I would expect that last bar to have some data in it instead of just 1. We've all seen online high score tables when it's been hacked. Now, this is the data from the 25 card test. And the first time I saw it, I was like, oh yeah, it's just more of the same. Wait a minute. There's something which absolutely bowled me over here, because in both the 5 card test and the 10 card test, the data is pretty much as I would expect from a binomial distribution. And this time I was like, oh, it's pretty close. No, it's not. It's not even close. Now, there's no one cheating. There's no one getting loads of really high scores. 25s are just not there. But the lower scores are underrepresented. 0s, 1s, 2s, 3s, and 4s. We're not getting as many as I would expect. We're getting a few more 5s than I would expect, and we're getting lots more 6s, 7s, 8s, and 9s than I would expect. And this is 16,000 results. This is not just a couple of people getting lucky. This is 16,000 people doing better than I would expect. And that surprised me, and that's why I got in touch with you, Matt.
So what on earth is causing this discrepancy, and why is it not evident in the 5 and 10 card games, but it is significant in the 25 card game? And as Ben pointed out, it's statistically significant. This is a real effect. We ran things like chi-squared tests and all of that. This is a real shift in the positive psychic direction. Well, we can rule a few things out. When I've mentioned this to other friends of mine, they've said, what if the random number generator is biased? It's not that. What if there's a bug in the code? It's not that. What if people are cheating? We're pretty certain people are not cheating because the distribution shape is still perfect. If people were cheating, we wouldn't get that binomial distribution. It would be weirdly skewed, or there'd be like a bunch of people who are cheating and people who aren't. The most anyone got was 13 cards correct. And while that's incredible, that's over 50% accuracy, we'd kind of expect it with that many trials. If people were cheating, we would see a bimodal distribution. There'd be another peak for the people who are cheating and then a peak for the people who are not cheating. But the shape is perfect, right? The data is solid. It's something else. If you want to try and work out what it is, I'm going to give you a moment, pause the video now, and write down your answer. Are you ready? Here's what was happening. People were quitting. The website only recorded the data if someone completed all the trials they'd signed up to. And for the 25 one, a lot of people didn't carry on. And here's the thing about humans. If it's not going their way, they quit. If it's going well, they carry on.
So we got suspicious and we had an idea, but we weren't collecting enough data to know if that idea was right. The idea needed to check whether people are quitting before they finish the game. And at the moment, my website is not recording that. If people shut the browser down, that game is gone, never gets recorded in my spreadsheet or on their graph, which is maybe why they're quitting. So since the 1st of July, I started checking the data and including whether they finished the game. So this spreadsheet I'm now looking at has the number of trials, game they were trying, the number they got through. If they finished the game, they got all of them, the number they got the correct, and then whether they actually finished. And it means we can filter the data by the finished games, but we can also look at the unfinished games, which I wasn't capturing before. And that was interesting because of the averages I have here. In the 5 trial game, people who finished the game averaged about 20% right. That's a fifth, that's 1 in 5, that's what I would expect. The 10 game, 21%, about right. 25 game, 21%, about right. And those are the people that finished the game. The people that didn't finish the game, 8%, 9%, 12%. They are doing worse than expected, and I think this is pretty solid evidence that the people who are quitting the game before they finish are doing worse, and therefore we lose in the data the worst scores.
But how does the average look if we combine finished with unfinished trials?
Let's find the average for both the finished and the unfinished, because I haven't actually done that yet, Matt. Good call. Let's find... Strange vibes coming through the ether. Average if... No, let's spell it right. Average if. Where the criterion is over here somewhere, I want to... If column B is the same as that value, then average the proportion they got correct. I think that's all we need. Look at that. Copy that down. These are the averages, Matt, of everybody. And you can see that for the 5-card trial, 19%, 19.4%, pretty close to the 1 in 5. The 10-card trial, 20%. The 25-card trial, 20%. That is the real, what you'd expect, but because we never see the unfinished unless we record them separately, it's skewing our data.
So this was a case of survivor bias. People doing badly did not end up in the data set. People doing well did. And there's other ways you can get survivor bias in data sets. This is an interesting one. This is rage quit survivor bias. And so that shift of the distribution, it turns out we've not got statistical evidence that humans are psychic, but we have got very precise statistical evidence that humans rage quit.
So we got suspicious enough to try and model the behavior that we thought we might be seeing, this boredom or this rage quitting. At the moment on the graph, you can see the green bars are the actual data. We got the thin green bars, the actual data we got that was a bit shifted over from what we might expect. The orange bars, slightly fatter in the background, are what we'd have expected. That's what gave us the alarm bells in the first place. But behind that, the blue bars are my Python model. I did some terrible Python code. Thanks, Matt. You inspired me. And at the moment...
I'm very proud.
I'm glad you're proud. At the moment, it's a 0% chance of rage quit, as it says up here. That means I'm just sampling from a binomial distribution. I've done 100,000 samples, and as we expect, it's matching the orange things. Now, the 0% chance isn't obvious what that means. If I increase that number, what it's going to mean is if people, or if my sampling process starts doing worse than 1 in 5 right, it might quit. And the might is captured by the percentage. So at the moment it's 0%. If it was 1% there, it means 1% of the time, if people are doing worse than expected, they will just close the browser and quit. And as you change that, you can see the graph shifts. It's cranking all the way up to 100% chance. So it doesn't sort of make you likely to get 25 out of 25, but you can see it does shift the bars to the right. So when it's high, it doesn't mean you have psychic powers. It just means we're losing the data, which is worse than 5, and proportionally to how much likelihood of rage quitting they have. Clearly, when that percent chance is high, these bars are not matching the data we've got. But if we actually look at a slightly smaller percentage value and focus in, then we see the sweet spot. Seems to be a 3% rage quit model is about capturing people's behavior on the 25 card version of this game.
And it will be more complicated than that. You might have to get a couple wrong before you quit. But just that very simple linear model, 3% chance of quitting on any wrong card, very closely matches the data we got. So while I cannot say anything about if humans are psychic, I can say that on average, statistically significantly, humans have a 0.03 rage quit propensity.
It's just a game that I made to demonstrate some maths facts. But there is a serious point, I think, which is data can go wrong in ways that are subtle. And there's a serious sort of real world demonstration of this. A campaign by a friend and colleague of us in the science communication world, Ben Goldacre, is running a campaign called All Trials, where he talks about medical research, maybe drug research. And let's put it in context. If you're testing a drug and you want it to be beneficial, then maybe you're more likely to publish your paper if it is beneficial, if you get the right results. But that also then might mean you're less likely to publish if you don't get the positive results. And as we've just seen, that tends to mess up the data. And this is why Ben's campaign to make sure that all trials are published, not just the ones that people are pleased about, is actually a big, serious, important part of research.
And here's a fun fact. It turns out we couldn't say anything about the traditional Zenocard test anyway, because Ben was writing the website for a maths lesson and not an actual psychic test. It was way easier to program the random card allocation after the person had already picked their card. So in reality, the person selecting the card and then the random number generator is picking what it is. So it means actually Ben wasn't testing if people are psychic, he was testing if they could predict the future. Sponsor message time. This video is brought to you by Jane Street, and their global internships are now accepting applications in all offices, New York, Hong Kong, and London. And if you enjoy looking for patterns and explaining weird trends in possibly quite complex data, I can highly recommend an internship, paid internship at Jane. Oh wait, hang on. I'm being contacted by myself in New York. As well as being a paid internship, Jane Street will cover your accommodation costs and your travel costs, whichever city you end up in. They have offices in Hong Kong, New York, where I am now, and London. And there's a chance you might get to see me. I often drop by to see the interns. I was actually just in the Hong Kong office to say hello to the previous cohort, and next time, that could be you. I mean, also it's good for your career. I mean, I'm just a, small bonus. So if you or anyone you know is curious about a career and the kind of work that Jane Street does, the details are in the description, and you don't need to have a background in finance. As long as you've got a curious mind and a collaborative spirit, you will fit in here at Jane Street. And last internship, they had people from 22 different countries across over 100 different universities. It really is a wide range of people who all enjoy math and problem solving. And so thanks again to Jane Street for sponsoring this video. That's it. Thanks for watching the video. Thanks to Ben and Tim Sparks for making this all possible. Huge thanks to Ash Price for getting involved. And thanks to the Voodoo Rooms, this fantastic bar in Edinburgh, who let us come in and film. And so, for one last time, what card am I holding? Oh, I think it's the subscribe button. You should click the subscribe button. It's the star.
I used to run a game show at the Edinburgh Fringe, and one of the rounds of the game show was called Play Your Zenocard Right, and we'd have the 5 cards handed out to members of the audience, and a participant given a duplicate set of 5, and they had to try and match each of the cards with those in the audience. And we had participants get that right on quite a few occasions, actually.
That was me, wasn't it?
It was you, yes, Matt.
I remember that. It was a lot of fun.
You are clearly psychic.
Whoa.
Let's not go that far.
Yeah.